Hey, I'm Andrew Johnson, and this is my lab for oscillations for Physics 2211. The purpose of this lab is to investigate the motion of a spring mass system that was given in a video with the mass oscillating in an arc. Tracker is used to track the object's position, and glow script is used to predict and update an object's motion and energy. A preview of the results is that the system's total energy remains constant at zero, demonstrating the energy principle. There are two models that are used in this simulation. First is Newton's second law, where the net force is equal to the spring force plus the gravity force, because these are the only assumed forces acting on the object. And the energy principle, where the change in energy is equal to the work done on the system by the surroundings plus the heat. The system is set to be the mass, spring, and earth, and the surroundings are set to be none because if everything that is acting is giving a force on the object is in the system, it keeps the energy principle constant at zero. The observed motion can be found here, where the initial velocity was calculated to be 0.0158, negative 0.00960 meters per second, and the initial position was negative 0.129, negative 0.615 meters. Finding the initial conditions, you need to solve for the oscillatory period, or t, which is 2 pi times the square root of m over k. In solving for k is equal to 4 pi squared times the mass over the oscillatory period squared. Then you need to solve for the relaxed length of the spring, which the net force of the spring is equal to negative k times L minus L naught L hat, plus the force of gravity, which is mg y hat, is equal to 0. Here's the code that was inputted to you can see the initial positions where the mass was given at 0.402 kilograms, and the position and velocity was just updated from what was calculated earlier. Here's the code that was used to calculate all of the spring force and the energy principle, like K, the potential energy of gravity, spring, and then the energy is set to be 0 because everything that is acting on the object is in the system, so the energy principle is constant at 0. Here's the loop that was used to update the position and energy and estimated position of the spring. And then here's the observed versus predicted model. As you can see, both the X and Y, the model and experiment is relatively similar, meaning that the model was successful. Here you can see the predicted energy in the system that was calculated by the loop. There are two possible potential errors. First is there's inaccurate center of mass on tracker, where there are like tracker errors, and then system not being truly isolated from its surroundings, like the force not being solely the spring or gravity. The question was, for your model system, is the energy principle satisfied? And yes, the energy principle is satisfied because in the model, the delta E is equal to 0, and there's no heat or work acting on the system by the surroundings because everything is assumed to be in the system. And then also we needed to compare oscillating periods, where the estimate was about 1.5 seconds in the X direction and 1 second in the Y direction for each period. And the actual was about the same, as you can see in these graphs. The actual versus the experimental versus model graphs have relatively the same periods. Thank you for watching.